6-8. We are talking about geometric sequences today. So, yes. Will what be on Canvas? The video? Yeah. But you should take notes with me right now. Yeah. All right. So here's what we're doing, okay? A geometric sequence, you've probably done stuff with this before in other classes, but maybe not where you set it up as an equation to help you find the next thing of the geometric sequence. But it's essentially finding a pattern in some set of numbers. So a geometric sequence, first of all, is this: a sequence of numbers in which, apparently we need to unplug because it's doing goofy things. The ratio, which in this case is going to be an R for our formula, and your ratio is going to remain constant. What does it mean to remain constant? The same, unchanging, okay? So you're gonna have some R value, and that R value is not going to change, okay? It's gonna stay the same through the whole problem. It gets you that R, that common ratio. We call it the common ratio because it stays common throughout, okay? Here's how you find it, and this is probably the trickiest part for people when it comes to geometric sequences. It is found by dividing each term. What did I just write? By dividing. Oh my goodness, you guys. There we go. It is found by dividing each term by its, and I want you to write this in all caps so that you don't forget it, because this is what gets done wrong all the time. Its previous term. Okay? What does previous mean? The last, the one right before, the previous term, the term right before it. Okay? Let me show you what I mean by that. If you are given this setup, 2, 10, 50, 250, okay? If I want to find the common ratio, the R for this, I need to take the second term and divide it by the previous term. What's the previous term to 10? 2, okay? So what you're going to do is you're going to go 10 divided by 2. What is 10 divided by 2? 5. Okay, so if this is a geometric sequence, then that 5 should stay constant all the way through the problem. So now you go to the next thing. 50 divided by the previous term. What's the previous term? 10. So 50 divided by 10 is 5. Okay? Then you do it again. Your next term, 250 divided by what? 50, the previous term.
We just gotta find that.
When all three of those are the same number, that means your ratio is constant. Your common ratios stayed the same. That means it is a geometric sequence, okay? So in order for it to be a geometric sequence, that number cannot change, okay? Is this a geometric sequence? Did my number change? No. So that is a geometric sequence. And you would say R, your common ratio, is 5. That is your answer to the problem, okay? Is it a geometric sequence? Yes. Your common ratio is 5. Okay, let's try another one. Here's where I think people get mixed up. Number 2 is 135, 45, 15, 5. And people go, oh, I see it. You're doing what? Dividing by 3. So then people tell me their common ratio is 3. It's not, okay? Geometric sequences, you're multiplying by something. So here's what you have to do. You take a term and you divide by what?
15. Oh, no, 130.
The previous term, the term in front of it. 135. Okay, get your calculator out.
I think I forgot one. I'll literally open it.
You should have a calculator with you, not an iPad. Where's your calculator?
I have one. I have one.
Ever?
I think I have one at home.
What do you do on quiz? Do you borrow one of mine every time?
Yeah. You can use mine.
Get a calculator.
Is that one? I just.
Take it to school. Okay, so 45 over 135. If you plug that into your calculator, what do you get?
Negative. 0.3. You get something.
0.333333333. Okay, that's not a nice number. How do you turn that into a fraction on your calculator? That S to D, right? If you don't know how to do that, talk to me because this is the number you want. I don't want 0.3 repeating. I want the fraction.
1 over 3.
1 over 3. Does anyone need help finding that button? So you're going to go. See this F? Oh, it's F to D. So second that, enter. We'll turn it into the fraction for you. Anybody else? Yours is a different button. So you're going to go math and then fraction. Enter. So we're gonna turn it into the fraction for you. Yeah.
Can we just skip the division part and just put it through the fraction? Let it go again? Because it really was it regardless. Like,
Can you what?
like, instead of doing this, like, every time, 135, and just getting that, like, I prefer to use it. Like, will it be wrong if I just put in the number, like, regularly?
Like if you go 45 times a third, 15
Yeah,
times a
just
third.
like this. Like, just putting in a fraction and then giving the answer.
No, yeah, it's doing the same thing.
Okay.
It's reducing the fraction for you.
Okay.
Okay, so when you do this, you get 1/3, okay? So then your next one, you're gonna go 15 divided by what? The previous term, 45. 15 over 45 is 1/3. Your next one, you go 5 divided by the previous term, which reduces again to 1/3. So every one of those reduces to the same thing. So that is constant, which is what we're looking for. Is that a geometric sequence? Yes, because you kept that same number all the way through, okay? What is your R? 1/3, okay? If you tell me R is 3, because you go, oh, I'm dividing by 3, it's wrong. I need to know what are you multiplying by each time, okay? So just be really careful with that setup. Take a look at this next one. Look at number 3 and try that process yourself. So you have 6, 18, 24, 30. See, is it a geometric sequence? And if so, what is your common ratio? So write it out, calculate what needs calculating, and we'll go from there. What are you plugging in here on number 4? Negative 14 divided by, what's the previous term? 7. So you get a negative 2. Okay, then you go 28 divided by what?
28 divided by -14.
Negative 14, also a negative 2. And then negative 56 divided by 28, also a negative 2. Is that a geometric sequence?
Yes.
Yes. And what is R? Your R is the negative 2. Does that make sense?
So if it's not, do we just put no?
Mm-hmm. Yeah, if it's not, there's no R to find because it's not a common ratio. It doesn't change the same amount each time. So you just say no. Can anyone tell me what the R is on number 5? It's a negative 1/2. It's negative 40 divided by 80. 20 divided by negative 40. Your R should come out to a negative 1/2. I'm not going to do all the work on that one, but that one does work. Good on that?
Yeah.
Okay, so here's the next thing that you'll do, and sometimes we'll put these parts together. It says, given the geometric sequence. So now instead of having to find is it, they're telling you it is. Okay, so this is a geometric sequence. Find the next three terms. So
In this case, would you
multiply what?
the numbers?
So we still have to know what it's changing by each time, and it's always multiplying by something, okay? So you still have to do the same process. You have to go negative 21 divided by 7 is a negative 3. The thing is, because they told you it's geometric, you don't have to do it with the next two. We know it's geometric. So once you've found it on these ones, you don't have to keep checking them unless it says, is it geometric? But it says, given the geometric sequence, so they're telling you it is. Okay, so now here's the question. How do you get to the next term?
Multiply 63 and negative 32.
By that number. So you are multiplying by whatever number you get here. So you're going to go 63 times negative 3. Okay, plug that into your calculator. And you get a negative 189. Okay, how are you going to find your next one? Multiply by negative 3 again. So just leave it in your calculator. You should have a negative 189 there. Just go times negative 3. And you get 567. Okay, do it one more time. Times negative 3. And you get negative 1701.
Yeah.
Okay, so you are constantly multiplying by the R. Does that make sense? All right, tell me how you would find R on number 8.
Subtract.
Not subtract,
No, you would divide.
divide.
But
Yep.
then once you find that, you would subtract it because it's decreasing, right?
No, we're not subtracting. You're always going to multiply, but you're going to multiply by whatever this R is. So plug this into your calculator. 768 divided by 3072, 0.25 or 1/4 if you like the fraction better. I don't care which of these you use when you're doing the multiplication, okay? So you would go 192 times 0.25 or times 1/4. What do you get? 48. Okay, then hit it again, times 1/4. You get 12. And then times 1/4 again. And you get 3. Okay, so each time you're going to multiply the previous number by whatever that R came out to. So if it's a fraction, multiply by the fraction. Don't divide, okay? You could think of this as each time you're dividing by 4, and then you just need to keep dividing by 4. But technically your R, your common ratio, is 1/4 because it's what are you multiplying by, okay? So what is it on number 9?
0.5.
Yeah, 0.5, 1/2. 4 divided by 8 is 1/2. So you are multiplying by 1/2, multiplying by 1/2, multiplying by 1/2. So 2 times 1/2 is 1. What's 1 times 1/2? 1/2, or you could say 0.5. And then 1/2 times 1/2? 1/4 or 0.25. So pick the decimal or pick the fraction. I don't care. But one of either of those is good. Questions on that? Okay. Can I just show you something? Maybe you've noticed it already. On this one, the number, now granted, positives and negatives change, right? But the number itself, if it was the absolute value of the number, the positive version of the number, if the number's getting bigger, you're multiplying by a whole number, right? If the number is going down, if the number is getting smaller, you're multiplying by a what? A fraction or decimal. Yeah, so this was 1/2, this was 1/4. They were getting smaller as we went from left to right. Okay, so that's a good way for you to check, am I multiplying by the right thing? If you're multiplying by a whole number, that number should be getting bigger. If you're multiplying by a fraction of it is less, it's getting smaller, okay? Questions on that? Okay. I have a formula for you, and I will give you this formula at the top of your quiz and test, but you need to know what everything stands for. You need to know what is a sub 1 and what is n, like what do those things represent. So the formula is this, okay? It says, put this off to the right side because we're going to put our other things off to the left. A sub n equals a sub 1 times r to the n minus 1 power, okay? So I will put this at the top of every quiz and test that uses this formula. So you will not have to have the formula itself memorized. What you need to know is that a sub n is talking about the nth term. So if I ask you to find the 7th term, I would say find a sub 7. I'm saying find the 7th term, which means n is the term number in the problem. And a sub 1, any guesses based on what I just told you about this? A sub n is the nth term, so a sub 1 is the first term, okay? So a sub 1 will be the first term, the first number in your sequence. Okay, so now we're going to kind of take some of what we've talked about already and put it into this formula setup. Oh, I didn't tell you R. Sorry. R is your common ratio. Okay, so let's look at number 11. We need an a sub 1 if we're going to plug it into the formula. So the formula, like when it says write the rule for the nth term, the rule is going to be a sub n equals, and we're going to fill in the rest of the formula. But I need to know what my a sub 1 is to be able to fill it in. What is a sub 1 in this problem? 3. It's your first term. So a sub 1 is 3. Okay. I also need to know what r is in this problem to be able to plug that in. 0.3 or 3? You take the second term and divide by the previous term, right? So that's your r. Your r is 3 in this one. So I'm going to plug into this formula, a sub n equals a sub 1, which we said was 3, times the r, which we said was 3 also, to the n minus 1 power. So when they ask for the rule, there should be no number plugged in for n, okay? This is the rule. Then they'll say, okay, now that you've found the rule, what is a sub 7? What do you think that means? What am I looking for? The 7th term. So if I went 3, 9, 27, that's 3 terms. The next one, the next one, the next one, the next one. Well, rather than have to do all that math over and over and over again, this formula is going to do that for you. So you're going to get to just plug something into your calculator. What's going to take the place of n? 7. So if I plug a 7 in here, then I have to plug a 7 in there also, okay? So I'm going to go a sub 7 equals 3 times 3. And you know what? Maybe we want to just get in the habit of doing this. It's probably best if you put parentheses there in case that's a negative number. To the 7 minus 1. Is there a simpler way to write that? 6, okay? So you're going to plug into your calculator 3 times 3 to the 6th power. Plug that in, and let's just make sure we're all getting the same thing. What did you get? 2,187. So a sub 7 is 2,187. Okay, so those are the two parts, part A, part B, okay? Tell me the formula without the n's plugged in, and then find the 7th term. Did anyone not get 2,187? Because I would love to show you how to get that in your calculator correctly. Okay, so go on to number 12. Let's think about the pieces we need from this setup. Can you tell me a sub 1 for this sequence? -4. It's your first term. So a sub 1 is -4. Can you tell me r in this sequence? -5. R is going to be 20 divided by the previous term. So 20 divided by -4 is a -5. So R is -5. Okay, so we have our a sub 1 and we have our R. Those are really the things you need to be able to plug in to this formula up top. So your rule is going to be a sub n equals a sub 1. A sub 1 is just a placeholder for the first term. So don't put the little 1 in once you've put the other number in, okay? Our first term is -4. So you go -4, and then we're multiplying by R. And again, I would just use parentheses. So -4 times -5 to the n minus 1 power. Okay, when they ask you for the rule, this is the rule. So the rule for the nth term is this. We want the 7th term. What are you going to do?
7 minus 1 is 6.
You're going to plug in a 7. So a sub 7, in other words, the 7th term, okay, a sub 7 represents the 7th term, equals -4 times -5 to the 7 minus 1, or to the 6th power, because you're plugging a 7 in for n. Plug that into your calculator exactly how you see it. What is your 7th term? -62,500. Okay, so I want the rule with n as n, but I want the answer with the 7 plugged in for n. Does that make sense? Okay, I want you to try this last one here, number 13. Okay, tell me what you're using for a sub 1, tell me what you're using for r, and then give me the rule and find the 7th term of that. What a sub 1 was? 400, your first term. Okay, and then what was r? 1/2 or 0.5. Be careful not to call it 2. It's easy to think like, oh, 200 times 2 is 400, right? But you have to take the second one divided by the first one and then reduce that. So you can call it this or you can call it that. Technically, it really doesn't matter. Either one. If it's a repeating, like 0.3 repeating, then don't use the decimal because you won't get the right answer because you'll plug it in as 0.3 instead of 0.333333333, right? So those are different. Then err on the side of fraction. Okay, so we have a sub 1, we have r. Can anyone tell me what you put in as your equation? A sub n equals, what came first?
100 and parentheses you put 0.5 and then n minus 1
To the
7
n
minus
minus 1. Yeah. So the rule, we don't want a 7, right? The rule we want n because now I can find the 8th term or I can find the 15th term or I can find the 100th term using this. Okay, I can plug whatever number I want in for n. So we want to leave the rule with n. But then when they say, okay, now find the 7th term, that's when you plug the 7 in. So a sub 7 is 400 times 0.5 or 1/2, if you want to do 1/2, to the 6th power, because it's 7 minus 1.
Isn't it 6 point? Well, I got
6.25, yeah.
Right?
So you get 6.25 as your 7th term in this process. Questions on that? Okay, the biggest place that I see mistakes is people finding the R. The R is always going to be the second term divided by the first term, okay? Just keep that in mind.